Good morning. So now we are going to study how to draw ray diagrams in case of concave mirror. Now this is a case of concave mirror. So center of curvature and focus will be in the front side of the mirror. So first let us see which rays we have to consider while drawing the ray diagrams in a concave mirror. So first ray is ray parallel to principal axis. See, this is the first ray which is coming parallel to the principal axis, and after reflection it will pass through, it will converge at F. This is a case of concave mirror. So it converges the rays after reflection. So when ray come parallel to the principal axis, it will converge the rays at focus. See, this is a case of reflection, so it will follow the law of reflection. Law of reflection suggests that angle of incidence will be equal to angle of reflection. Now, angle of incidence is the angle between incident ray and the normal. Angle of reflection is the angle between reflected ray and the normal. So, which is the normal in this case? Normal is a virtual line which joins center of curvature and the point of incidence. So, this is the first ray which is parallel to the principal axis and it will converge at F after reflection. Second ray is passing through the focus. So, whenever ray passes through the focus, after reflection, it will become parallel to the principal axis. We can say that rule number 2 is exactly opposite of rule number 1. Now in this case, in this case also, it will follow the law of reflection. That is, angle of incidence is equal to angle of reflection. Now, see, this is the angle of incidence, which is the angle between incident ray. This is incident ray which is passing through F, and this is the normal which is joining center of curvature and the point of incidence. So angle of incidence is equal to angle of reflection. Third ray is passing through C. Whenever ray passes through center of curvature, it actually bounces back in the same direction. Why it happens? Now, it happens because this is a case of reflection, and according to law of reflection, angle of incidence will be equal to angle of reflection. And in this case, angle of incidence will be equal to 0. That's why angle of reflection will also be equal to 0, and ray will bounce back in the same direction after reflection. Now fourth ray is passing through P, that is pole. See, here we are considering the case that ray is falling obliquely on P. Ray is not falling through the principal axis on P. Because if the ray falls on P through the principal axis, then it will follow the third rule and it will bounce back in the same direction. But in this fourth case, ray is falling obliquely over the P. That's why it will follow the law of reflection, and after that it will reflect obliquely from P, and it will follow the law of reflection that says angle of incidence will be equal to angle of reflection, and here normal will be exactly the principal axis. So we are done with the rules to draw the ray diagrams in case of concave mirror. Now let us see how to draw ray diagrams actually in case of concave mirror. This is the first ray diagram in case of concave mirror, and in this case the object is placed at infinity. While drawing the ray diagrams, we need protractor, we need scale, we need eraser and a pencil. Now in this case I'm drawing the ray diagrams with a black pen, but black pen is not allowed in your exams. It is just to highlight the ray diagram properly. I'm using black pen. Now let us draw the mirror, concave mirror, with the help of protractor. Keep the backward portion of the concave mirror to be shaded, otherwise it will be considered as lens. Draw the principal axis. Locate P, F and C such that PF is equal to FC. C is center of curvature, F is focus, P is pole. Pole is the midpoint of the aperture, that is the spherical part of the mirror. C is the center of curvature. In case of concave mirror, C, that is center of curvature, and focus, that is principal focus, will always be in front of the mirror. Now, in the first case, object is placed at infinity, so all the rays will come parallel to the principal axis. These two rays are coming parallel to the principal axis, and the third ray is coming through the principal axis. Now, as we know that when the rays come parallel to the principal axis in case of concave mirror, they converge at F. So here image is formed at F. Its nature will be real and inverted. Real means we can capture the image on the screen. Inverted because it's upside down. Its size is point sized. See, here we can't see the image is inverted because it is a point sized image and its location is at F. Keep some space here because after learning the sign conventions, we are going to write few details here. Now next case of ray diagram is when the object is placed beyond C. Now the object is placed beyond C, but it is at finite distance. First case was object was placed as at infinite distance. So first draw the mirror. Keep the backward portion of the mirror to be shaded. Draw the principal axis. Locate P, F and C in such a way that PF is equal to CF. In case of concave mirror, center of curvature and focus will be in front of the mirror. Now, this is the object AB, which is placed at a finite distance but beyond center of curvature. So, here we are considering two rays while drawing the ray diagram. See, while drawing any ray diagram, you have to consider two or three rays out of the four rays which we have discussed previously. So here we are considering rays. First is a ray parallel to the principal axis. We know that when the ray comes parallel to the principal axis, after reflection, it will converge at F. Second ray we will consider a ray passing through C. We know that when the ray passes through C, after reflection, it will bounce back in the same direction. Now, these two reflected rays meet at this point. So, image will get formed here. The image will be real and inverted. Why real and inverted? Because it is upside down. So its nature is real and inverted. Real because it can be captured on the screen. Its size is diminished, smaller than the object, and its location is between C and F. Now let us consider the third ray diagram when the object is placed exactly at C. So let us draw the mirror first. Keep the backward portion of the mirror to be shaded. Draw the principal axis. Locate P, F and C such that PF is equal to CF. Now our object is placed exactly at C. First ray we have to consider that the ray parallel to the principal axis. When the ray comes parallel to the principal axis, after reflection, it will converge at F. Now secondly, we will consider a ray passing through focus. Whenever ray passes through the focus, after reflection, it will become parallel to the principal axis. So this is the point where image is formed. So the image is real and inverted. Real means it can be captured on the screen. Inverted because it is upside down. Its size is same as that of object and its location is at C. Keep some space here because we are going to write the details after understanding the sign conventions in case of mirror. Now, fourth ray diagram is when the object is placed between C and F. Now, object is coming closer and closer to the mirror, and you can see the size of image is increasing. The object is coming closer and closer to the mirror and size of the image is increasing. So first draw the mirror part with the help of protractor. Draw principal axis, locate P, F and C. P is the midpoint of the aperture, that is called as pole. C is the center of curvature of the mirror, which is in front of the mirror. Now, the object is placed between C and F. Now, first ray we have to consider it as a ray which is coming parallel to the principal axis. Now, we know that whenever ray comes parallel to the principal axis, after reflection it will converge at F. Second ray we will consider the ray which is coming from the back side of the object, that is from center of curvature C. Now why we are considering this ray? Because this ray after reflection it will bounce back in the same direction, so it is easy to draw this ray. So at this point image will get formed, which is again real and inverted. Sorry, while drawing this image I didn't check that it is not coming in the camera properly. It is not getting shooted properly. So we will discuss this image again. Let us discuss this image again. Now in this case, object is placed in between C and F. So first ray will pass in such a way that it will be parallel to the principal axis. Now we know that whenever ray is parallel to the principal axis, after reflection it will pass through the focus. Now second ray in this case we will consider it as the ray coming from the back side of the object, that is from C. Now why we are considering this ray only? Because this ray is easy to draw after reflection, because this ray bounces back after the reflection. So this ray is getting bounced back after reflection, and both the reflected rays will meet at this point and the image will get formed at this point. Its nature is real and inverted. Why real? Because it can be captured on the screen. Its size is enlarged. Enlarged means it is bigger than the object. Location is beyond C. So this is the fourth case when the object is placed between C and F.